Hello, good evening, you all. We will see our next question in this video lecture. This is a question number 2. In the previous class, we have seen question number 4 as it was a basic and a easiest question. So, based on the previous question, we will study this one. Okay. So, here the gear train is shown in the figure. Gear A meshes with gear B. Gear A is meshing with gear B. So this is a gear B. In the compound gear BC, so B and C constitute a compound gear. Gear C meshes with gear D. Gear C is meshing with gear D. So can anyone identify which kind of a gear train it is? It is the reverted gear train, which we have seen in the kinds of gear trains. Okay. So A is connected with B, B is connected with C, and C is in turn connected with D. This kind of a gear train is nothing but a reverted gear train. Fine. Okay, now gear C meshes with gear D, rotating relative to A around the same axis of A. Around the same axis of A, all the gears are having a rotation. If the gear A is fixed, okay, arm F is used as a driving member. Determine the speed ratio ND divided by NF. ND divided by NF. Here F is nothing but a arm. And number of teeth on the wheels A, B, C, D are given 61, 61, 62 and 60 respectively. Okay, write down the given data first. And as I have explained in the previous lecturer, that the mentioning or noting down the driver gear and driven gear are so important when you are solving the tabular method questions. Tabular method questions. So this is going to be a very important to be considered. Fine. Okay, now. So can anyone identify? So which is a driving gear? So definitely A is a driving gear here. Because A is meshed with B first, then this compound gear is meshed with D. So that's why gear A becomes a driver gear. See, A becomes a driver gear, and when A becomes driver gear, A is connected with B. Okay, A is in contact with B. Definitely B becomes a driven, because the B is following the A. That's why B is a driven gear. Then even it is possible that one more row you can add, that is B as a driver gear and C as a driven gear. Yes, it is possible. As it is a compound gear, I have not written those things directly. C becomes a driver gear and C is connected with D, so D becomes a driven gear or follower gear. Okay, this much data you must understand before going to the table. Fine. Okay, now let us move to the table. Again, fix the arm and give +1 revolution to gear A. So what will happen? So fixing the arm means it becomes a again simple and compound gear trains. Okay. So arm F is 0 and gear A makes 1 revolution. This is the given. Means we are assuming that we are giving +1 revolution to the gear A. Okay, now compound gear BC, how it rotates? See, A is connected with B, right? So what is the train value formula? It is the ratio of number of teeth on the driver gear divided by number of teeth on the driven gear. So here driver gear is A, that's why this is very important, I said. So driver gear is A, driven gear is B. So ZA by ZB. And minus sign because A and B are rotating in the opposite direction. Fine. Okay, now how about the gear D rotates? So now if I give 1 revolution to gear A, first gear A will make gear B to rotate. Okay, once gear B start rotating, gear C will also start rotating, because these two are compound gears. Once gear C rotates, gear D will also start to rotate. This is what the explanation, right? Then how gear D rotates? Again you take the train value formula, ratio of number of teeth on the driver gears divided by number of teeth on the driven gears. Here the driver gears are which? A and C. Driven gears are B and D. So ZA into ZC divided by ZV into ZA. So that only I have written here. And the relation between A and D is that both are rotating in the same direction. You can see. Suppose if it is rotating in a clockwise, then this will start anti-clockwise rotation. And if this is anti-clockwise, the main C also rotates in the anti-clockwise. And C is connected with D, so D will make clockwise direction. Hence, A and D makes same kind of rotation. Hence, I have not taken negative sign. Clear? Fine. So once the first step or the first row is over, then it is very easy to solve. It's just multiply the x with the first row. So we will get 0 and x into 1 x into this quantity and x into this quantity, right? Then add y. Just add y to the second row. So you will get these values. Now what is the speed of the arm F? It is y. Speed of the gear A, x plus y. Speed of the gear B and C is this quantity. What is the speed of the gear D? This quantity. Now we know that where it is, gear A is fixed. Where it is? If the gear A is fixed, so this statement, if the gear A is fixed means x plus y is equal to 0, because this is the speed of the gear A. If this is fixed, x plus y becomes 0, then x is equal to minus y. Clear? And we need to find the speed ratio of ND divided by NF. That is speed of this quantity divided by speed of F, that is this quantity. This quantity by this quantity. So here ND by NF is equal to y plus this quantity divided by y. So you can take y common. Otherwise, one more step, y plus, put all the values of teeths A, B, C, D gears. Here are the values, and x is equal to minus y, isn't it? X equal to minus y, you just put it around. And take y common, it will be 1 minus this quantity, that is 31 by 30. So it is what? It is minus 1 by 30, right? 1 minus 31 by 30. Take the LCM, 130s are 30 minus 31 is minus 1, and 30 is the LCM, it is 30. So now ND by NF is nothing but minus 1 by 30. And here minus sign indicates ND, that is gear D, and arm F rotates in the opposite direction. Hope it is understood. Okay, we will see one more question in the same video lecture.